Grouping, our last real page. Grouping is tons of fun. It's what it sounds like. You have to group different things together in order to be able to factor the overall polynomial you have. So in the first one, we have 4 terms. We're going to group the first 2 and the last 2 together. Factoring out the common factor of the first 2, we have x times x plus 1. Factoring out the common factor of the last 2, we have y times x plus 1. So that the x plus 1's match, and we can factor out the common x plus 1, leaving us with x plus 1 times x plus y. In the next one, the first 2 terms don't have anything in common. So we're going to say, hey, let's rearrange. I want my terms to have things in common, so I can do a 2ax minus a 6ay minus 3by plus bx, just using the commutative property. And then my first 2 terms all of a sudden have a 2a in common, leaving me with x minus 3y. And my last 2 terms have a b in common, which leaves me with a negative 3y plus x. We have to recognize that that's really x minus 3y, using the commutative property again. And so we can factor out that common x minus 3y, leaving us with the 2 things that it's multiplied with, 2a plus b in the other set of parentheses. So we start to rearrange in number 3. We have 4x squared minus 4x minus y squared plus 1. While the first 2 have something in common, they wouldn't have anything in common with the last 2, which is a y squared. So we continue to rearrange, and we say, oh, hey, negative 4x squared minus 4x squared plus 1 is definitely something I can factor. So factoring this 4x squared minus 4x plus 1, it is a perfect square of 2x minus 1. So we used grouping to group all 3 of those terms together. That's where it gets super tricky, recognizing the difference between when you have to factor grouping 2 together and when you have to group all 3 together. Can just be hard. It takes practice. It takes looking at it and thinking about it. We still have 2 squares that are subtracted, so we have to finish this up with 2x minus 1 plus y and 2x minus 1 minus y. Moving into the third one, I'm going to have a squared minus b squared plus 8b minus 16. I could do the difference of squares on the first 2, then there'd be an 8 in common with the second 2, but there'd be no way to factor out what we get left from there. But if I factor out a negative 1 from the b squared minus 8b plus 16 now, I have a perfect square sitting over there of b minus 4. So now I'm factoring the difference of 2 squares again. I'm getting a plus b minus 4 times a minus b minus 4. Notice how I'm being very careful with my parentheses so that I remember to distribute for my final answer. Factoring by grouping. Our last page, which didn't even make it onto my notes because it is a entirety of review. What do you do when you have 2 terms, 3 terms, 4 terms? Has your formulas there for you. I hope you have enjoyed factoring. It is a wonderfully, wonderfully important topic. You guys are awesome. Hope you're having a phenomenal weekend, and I'll party with you on Monday.